Good. Well, I think we'll kick off. So welcome everyone to the webinar. It should be about half an hour. What we're going to do is we're going to describe the Hefring system and how it improves the safety and comfort of small boat operations. So I'm Nick Swift. As I say, a few familiar faces there. So I'm working as a business development consultant in the maritime industry and working with Hefring to promote this system into the maritime industry. And I'll be hosting this webinar. We've got a panel today, so I'm joined by KARL, who's the Chief Executive Officer at Hefring, and Reynar, who's the Chief Executive Officer and Captain of Whale Safari, which is a whale watching company in Iceland, and Professor Magnus, who is the Chief Technology Officer for Hefring. What we'll be doing KARL will be doing a sort of presentation on the system and what it does. And then we've got a kind of case study really from Reynar. We've got a video of how he uses the system to aid his tourist business. And then Magnus will go into a few more technical details on the system. We will be doing a question and answer session. As you see, we've got the whole panel here. So if you want to ask any questions, if you go down to the bottom of your screen, you might have to move your mouse over it, but you'll see a Q&A chat box. If you can put any questions in there, and at the end of the presentations, we'll have some, I'll go to the questions. Just final point, this webinar is being recorded. We will post it later, but that's just for your information. So with that, welcome again, and I'll hand you over to KARL.
Thanks very much, Nick. Thanks everybody for joining. My name is KARL BJÖRNSSON, CEO and one of the co-founders of Hefring Marine. Before I start, I'd just like to point out that if you are only seeing me and not seeing the slides, then you can go to change your view so that you can view the slides and the speakers at the same time. So giving a little bit of insight into Hefring and Hefring Marine. So Hefring Marine is a solution that we developed in order to prevent accidents that are caused by human errors in boating. And these are mainly down to accidents that are caused by inattention by the operator, for example, inexperience, and excessive speeding. Usually those are coupled together and often in conditions where they're not merited. So what does Hefring Marine do? It's a solution that monitors the vessel's motions, uses that data and processes it in order to provide the operator with decision support that allows them to adapt and optimize speed. And it logs and reports all trip data to make it accessible for live viewing as well as report format. Now, it has been shown to reduce impacts by up to 70% while in use, and it can improve efficiency by up to 30%. So for Hefring, we're focusing on, at the moment, on smaller boats, such as the ones shown in this video. So on boats like these, the operator will have a display, such as the one you have here, see on the screen here. Starting on the left-hand side, you have an impact gauge showing you the actual impacts being experienced in real time. And that gauge is split into three areas, where you have from low severity to mid severity to high severity impacts. Those are set by default in the system, but can be configured in the admin portal. The middle of the gauge shows you the actual impacts in real time. And at the bottom, you have an impact counter that counts how many impacts are being recorded above the higher tolerance threshold, which is by default set to 3G. Those impacts that are recorded are then used to calculate a safety speed or recommended speed, which is shown in the middle dial, the ROG, or the red speed over ground. Now that speed decision support tool adjusts itself continuously throughout the trip based on impacts and emotions that the vessel is going through. At the bottom of that gauge, you see the actual speed that you're doing so that the operator can compare the speed that is being suggested to the actual speed of the vessel. but the maximum ROG can then be configured in the admin platform. On the right-hand side, you then have a gauge with the duration of the trip, as well as the weather and sea state information. But then more features will be added to the screen at a later point in time, including whole body vibrations, a gauge showing vibrations being experienced over time, and how it empties over time throughout the duration of the trip. On the admin side, you then have a HM admin, a both monitoring and reporting tool that shows the location and route in real time, allows you to track speed and emotions of the vessel and the impacts that are being experienced, and track the behavior of the operator based on the actual speed relative to the recommended speed. After each trip, an automatic trip report is created, giving a clear safety profile of the trip itself, where you can benchmark performance between trips in terms of particularly safety, where each trip is then linked to a captain and a vessel, and the vessel and the operator behavior is clearly demonstrated in the profile. The system itself is based on a control unit and a sensor module in its simple form, linked to the display and then connected to a cloud for the admin console. So to summarize, it's a system based on monitoring of boat motions in order to generate a safety speed, as well as monitor impacts and speed in real time, and report formats that can allow for both tracking and analysis. Moving forward, we'll be adding features in our future roadmap, from route guidance based on weather for safety. From that, developing a heading that can be displayed both for the operator and in the admin portal, focusing on fuel efficiency to optimize consumption based on motions and speed. And then sectors that we'll be looking into going forward will be autonomous sector, both for remote and autonomous decision support, and at a later point in time, larger vessels as an area of interest. We worked with a number of very good partners and received some good local support here in Iceland. But next, I'd actually like to introduce probably our earliest partner, Whale Safari, and from them, Reynar Ottósson, CEO and captain, will be giving us a little bit of insight into their user experience of Hefring. Reynar, take it away.
Hi, everybody. Thanks for having me. So we operate whale watching tours out of Reykjavík on 12-passenger rib boats. And the weather can be a huge factor in our operations here in Iceland. There can be very windy conditions, and therefore we spend a significant time on making sure our tours are safe and comfortable for our passengers to operate. We use different methods for weather forecast and others to work out our things, but we are very excited that we've been working with Hefring, and we see it as a fantastic solution for our future going forward. KARL came by on the harbor the other day, recorded a short video where we talked a little bit about the advantages Hefring has been, giving us. And like I said, it gets windy in Iceland, and so the audio is still good on it. Maybe we'll just play the video, KARL.
Hi, my name is Reynar. I'm the CEO of Whale Safari in Reykjavík, Iceland. We're a tour operator on rib boats from the city center. We go out whale watching and bird watching. We do 2-hour tours on the whale watching tour, and we are on a rib boat like we are on now today. It's equipped with two 300 horsepower outboard motors and seating for 12 passengers.
What makes for a good trip, and what kind of experience are your customers looking for?
So first of all, people are here to experience nature. So our aim is to go out and get in best contact with wildlife. If it's mammals on the water or bird life. For the customer to be happy and to enjoy the tour, they need to feel safe and comfortable. And so, if they are experiencing comfort and safety, added with sightings of wildlife, that's a successful tour. We almost want passengers cheering when they roll back into the harbor, and that happens quite often on our tours. One captain came in to work with us, a marine biologist that has been a guide for us for many years. She started operating last year, so we had to look at, there are different factors to take in while training this new person. We had Hefring Marine gear on board, and we could actually show her while we were doing the testings how the effects on G-force in the front of the boat was affecting customers, and how she could relate to it in regards of controlling the boat, slowing it down, moving it, doing side wave cuts through the waves and such. So this is the first time we did a training using Hefring Marine.
So for training, you see that Hefring Marine would be a valuable system to have on board then for your new passengers, and you plan on having Hefring Marine as a guidance system on board for new skippers.
Yeah, so we started looking at it from a different angle than on the training aspect. We were looking at it for managing the tours, monitoring tours, monitoring crew on the tours, but we also found out that it could be quite valuable in the training aspect. And in the beginning, we were just looking at, okay, we're just going to monitor tours. We can monitor the boats better than any other systems we have. It's going to be partially grease management, it's going to be partial this, partial that, but the training aspect was kind of something that we didn't realize beforehand, and it was coming in quite handy. So maintenance on these boats is quite a lot, and they're always running on high output, many tours a day, and we were seeing that the engines were lasting sometimes not as long as expected. We were having more engine failures. We were seeing there could be some structural damages as well.
Other features that you would see as being beneficial in the system going forward?
So we were looking at these minor things, and a minor thing could be fuel consumption. We have maximum 12 passengers on our boat, and we can have a maximum 700 liters of petrol on it. The difference in weight on the boat between 2 passengers and 100 liters of petrol, or a full tank and a full boat of people, it can have a lot of effect on how the fuel consumption is, depending on how fast the engines are turning or how fast we're moving on the spot. So if we could see this, like just raw data on exactly how this works, this could also come in and we could use it just on saving money and running the tour more smoothly without people always trying to guess. We just know that this is the weight roughly, this is how many people we have on it, these are the sea conditions, this is the speed we're going to use, and we're going to be turning the engines around 3,800 or 4,200 RPMs. The system will probably just tell us, get the most efficiency out of it.
So you mentioned the allowable speed, or the speed that you allow. One thing that the system can do from the on-land system, the admin system, is you can set a maximum speed that you allow operators to go, or which is then visible on board, in the display on board. Is that something you made use of, and is that something you saw as being of interest in terms of setting standards or setting safety policies and potentially tying into other areas that could be beneficial cost-wise, such as insurance?
Perfect. We have been trying to have the discussion about, all right, so we can prove that we're not having any injuries. We're taking out roughly 10,000 people per summer on our tours, and it's going smoothly. There are no injuries happening since we started really focusing on this with new seats, with looking into Hefring, with extreme focus on making sure that we run according to conditions. With the system, after we've been using it and looking at all its potentials, we're just seeing so many different angles that we were looking at. So it's like fuel consumption, it's safety, it could be saving money on insurance, it could be fleet management. The angles are just everywhere. So our focus is just like continue to work with it and see what most we can take out of it. And yeah, we're just super excited about it because it's just the system is growing for us as a user much more than we expected it to.
Reynar, thanks very much. Always a pleasure.
Likewise. Good luck.
Thank you. Likewise.
Yeah. Thank you.
So thanks very much, Reynar. Now, I'd like to introduce our CTO, Professor Magnus Jónsson, who will be giving a bit of a technical review and a little bit of look at the data behind Hefring Marine. Magnus.
Thank you, Carl. And hi, everybody. I'm a professor in mechanical engineering at the University of Iceland, and I'm also co-founder and CTO at Hefring. In this presentation, next card, in this presentation, the focus will be on the technical issues. In the first part, I will define the impact load and the slamming. Then I will show how our system changes the operator behavior. And in the end, I will go through the data acquisition and signal analysis. Next, please. This slide shows how our system is based on two modules, that is the control unit and the sensor module. And in both we are measuring acceleration in both units. The left graph shows the acceleration at the console where the control unit is placed, and the right one shows where the sensor is placed. We measure the acceleration as a time series, but the impact is the peak. If you look at the left side, we see the peak there. This is the impact. Then the goes into the water, and we got the G-force through the structure of the boat. And what we see also in this picture is that at the console, the impact is around 2G, but at the front of the boat, where the crew or the passenger have placed, then it's around 6G. So it's more than 2 times higher. Next, please. What affects the impact load is the boat, the sea condition, and the operator. The boat, that is the hull type, boat length, and beam, weight and weight distribution. For the sea condition, that is the wave height, wave direction, and wavelength. And for the operator, he controls the throttle and the helm. And in our system, we are looking at these 3 main categories. That is the boat, the sea conditions, and the operator. And our system is then the co-pilot that is assisting the operator to choose the right throttle conditions, throttle control, and helm. Next, please. This slide shows how our system has changed the behavior of the operator. These are 2 trips, 2 2-hour trips. The left one is a trip when the operator was unaware of the sensor or the system. The blue columns there are the impacts. In the background, we see different white, light blue, and blue color that shows the weather condition or sea states. And as we see for these 2 trips, the sea state was very similar. But as you see there, the blue columns on the left side, when the operator was unaware of the sensor, the highest peak was 4.6 G and the average was 1.3. On the right side, when the operator was aware of the sensor, the highest is only 2 G and the average is around 0.5 G. So this shows us how the operator changes the behavior when he is using our system or he knows about our system. The next, please. This shows the reports from or graphs from our system. The difference between these two graphs is the resolution. On the left side, we use that for looking at the trip overall. This shows the 10 minutes part of a trip. The blue columns there are the peaks or the acceleration. And the red line is the ROG. That is the speed limit that we calculate or gives us the maximum speed based on the sea condition or sea states. And the brown lines shows the speed over ground, SOG. And on the right side, we show that how we can get this in more resolution. We show that this blue lines there, that's the impact each second. And this is the 5 minutes, it shows the 5 minutes of the last 5 minutes of the 10 minute trip on the left side. And as you see there, when the captain or operator follows the red line, that is the maximum speed, the impact's reduced, but then he increased the speed when the red ROG goes lower, and that results in this high impacts at this 6.3 G. And he does not follow the guidelines until the end of the tour, where it goes down, and that reduces also the impacts. So this concludes my presentation, and I hand it over to you, Nick.
Great, thank you very much. We've got some questions come in. So I'll start with quite a simple one for Reynar. So Reynar, when did you start working with Hefring?
We started 2 years ago, roughly, where we were doing some testings and testing out the gear ourselves. And then last year we were running tours every day for almost 2 months, where we would both use it as I said in the presentation, we used it in training, and we used to actually drive after and really focus on operating by the recommendations, considering conditions. So I would say 2 years, although last year was our first full season kind of running tours using the system.
Great, thanks for that. Gone to some more technical ones. Albert's got quite a few actually. So the first one is there any integration with navigational map, i.e. a chart plotter, potentially alerting to prevent grounding incidents?
I'll jump in for that. So in our upcoming version, we have our own navigation map, which is on the admin side, but the onboard display is actually being shown now on chart plotters, as you saw in the video there. And we're looking into potentials for ways to integrate the two. Ultimately, our navigation map that we have in our admin portal can also be viewed on board. And then for the second part of the question, to prevent grounding, the Hefring Marine system or the version we're working on now actually has a NEMA 2000 connectivity, as you saw on the slide earlier, and so could connect with any depth transducers on board and could make use of that data to alert for any potential groundings, as well as correlate that with the map. So it is indeed something we're looking into.
Good, thanks for that. Another one from Albert. Can you clarify on how the system improves operational efficiency, reducing fuel consumption and emissions?
I'll let Magnus maybe jump into that one.
We are working on that part now. What we measure is that our sensor are, I knew that is we are measuring in 9 dimensions. That is, we have this accelerometers in the three directions, and we are looking at the resistance when the boat hits the wave, and we see that the resistance from the accelerometers, and we are using that to estimate the fuel consumption. This is not in part of our system as in the front end, but we are working on that, and also we are working on how we can use it to estimate the fuel. But what we don't have now is that we are not connected to the fuel consumption of the boats, so that's something we need to add to the system.
Good, thanks for that. I'm aware of time. We've got quite a few questions. I'm going to do a couple more. We can overrun, but let me just get the priority ones out of the way within the half hour. So Philip asked, are you still in the testing phase? What are your ideas, plans to launch in the market? Is it ready to install on a small craft? Well, I know it is ready, but I'll let Carl pick up a bit more on exactly where they are. But it's important to say it is being used in operations as Reynar is. But Carl, do you want to go into a bit more detail?
Yeah, sure. So thanks for the question. It's we started last year with the first version of the system, which where we made use of a tablet and a Bluetooth connected sensor. That was sort of the first version / proof of concept to get the system out there. But then once we started getting requests for further integration into the boat, getting more data out of instruments on board, we knew we needed to expand into a more sophisticated system that could develop with the features that we wanted to add to the system going forward. So, for example, like Reynar has been using, I think, every version of the system that we have developed, and is always ready to receive any version that we bring to him. But we have now upgraded to a version similar to like the one you saw in the slide, where we have the control unit and the sensor. Control unit then integrating all the features that the tablet otherwise would have handled, such as connecting to the cloud, thereby internet connectivity, displaying to an operator, and handling any computing power that's needed. For the final version of that system, the planned launch for that is in August, where the finalized version that is made publicly available to the market is scheduled for August.
Good, thanks for that. Let me just have a quick look at another one from Colin. Colin, I've just messaged you directly, but here's another one. Can you preset parameters that, if exceeded, would sound an alarm? From as in Colin's experience, you drive a tender and relate it to how your body copes. You would not want to watch a monitor. So basically, can it have an audio alarm?
Jump into that one too. Yes. So the first version actually used the tablet for an audio alarm, and this version that we're developing now will also have these audio alarms, because we realize, as you rightly mentioned, that people aren't always staring at the screen as they're operating. We've also looked into some future possible options of connecting to smartwatches, for example, and wearables, where you might have either sound or vibration alarm. But a sound alarm, aside from a flashing gauge in front of you that draws your eye's attention, the system is also being implemented with a sound alarm setting.
Good, thank you. One actually, which is probably more for Magnus, I know we've talked about it quite before. How will you implement and show whole body vibrations? It's probably worth stating we have looked at whether we can use it for the regulations, the European regulations on whole body vibrations, and we can. So that's something that we're looking at. But Magnus, do you want to pick that up in a bit more detail?
Yes, we are now calculating the vibration dose values that the whole body vibration is based on, but we don't have it in our front end. Don't show how much dose the boat or the people on board the boat has got, and we don't show the limits. But we are working on how we should put it in the front end. And sure, it is a limit, and then it will be some kind of column bar that will show how much the boat has, how much vibration dose the boat has had over the trip, and how much is left compared to the European standards. That's what we are working on now, but we are calculating the vibration dose values.
Great, good, thanks. Just a couple more. The third question from Albert is the system, can you integrate the system with inboard four-stroke with traditional mechanical engine and analog gauges? And can you retrofit it?
Yes, so you can retrofit the system. It can be either built into the vessel when it's new, or it can be inserted when into an existing boat or an existing platform. So yes, that's a possibility.
Good. Let's just take, because I'm quite aware we're running over time a bit, so we'll just take one more. How will you be implementing future features, and what will the rollout be? Oh, actually, I've got another question as well. So take this one, then I've got one more. Future features and the rollout.
Yeah. So the version we're launching in August has a capability to run any software updates that we plan on introducing going forward. So the hardware itself that needs to be on board does not have to be replaced. It is there as a permanent system on board, sort of left out of sight, and the user interfaces with it obviously through the onboard screen as well as the admin platform. Future features will then be rolled out as software updates and software options, and where we can then tailor to different needs, different use cases. Having all of the data that is available on board, including the data from our own sensors, as well as data that we collect from NEMA 2000, allows us to start, in a way, playing a little bit around with that data, seeing what, in particular, working with users who might be interested in using particular data sets for any particular application. And from that, features will roll up. We know of some features that we do want to launch ourselves, such as the ones that I mentioned in the presentation, the route guidance aspect, the heading being a logical next step from speed, and a logical step toward having a co-pilot system, essentially. And so there's rollout both for features on board and rollout for administrative or tracking and monitoring features.
Good. And the final question, this is actually from me. Other than enjoying one of Reynar's whale watching trips, how can we see the system? The reason I ask is we're going to be doing some demonstrations in the UK, and again, if you want to pick up on that, Carl.
Sure. So the plan is to visit the UK. The scheduled date will be in September, due to ensuring that restrictions are lifted and we can freely travel everywhere. But the plan is for a visit to the UK in September, where we will make the system available for demonstrations and trials.
Good. I think because we're 5 minutes over time, so I think we'll have a conclusion there. Do you want to just quickly put up our emails again, that final screen, Carl? And if you've got any other questions or want to contact us directly, please do get in touch. Thanks very much for the panel. Thank you, Reynar. It looks a good trip, so I'll be quite interested in looking at the system from the boat, actually. And Magnus for the technical insight. So that's it. And we'll be running a few more of these. So if there's anything of interest, let us know. We've got it recorded, so it will be going up on the website at some point, and we'll send you all links. As I say, if you've got any more need any more information or any more questions, please let us know. Thank you very much.
Thank you, everyone.